let's see what is the story about Pandas. Now, as I said, the main tool we're going to work with is Pandas. That's what it helps us to work with data. Now, Pandas is built on NumPy. I shared with you an article about NumPy and how it actually kind of revolutionized the way we do numerical computing in Python and the way it defines arrays. Pandas is built on NumPy, or NumPy is used as a big part of Pandas. We'll talk about a lot of these other libraries I mentioned here. Pandas has some capabilities of matplotlib in it already as methods when you import data frames. It has a lot of good tools to manipulate the data so it can be ready for any kind of processing you want to do using any kind of machine learning or data analysis toolbox. Right? And the last thing I put there I have to mention is that small difference. Well, it is a small, but it makes a big difference between these two things, between NumPy and Pandas. Pandas is very capable of dealing with different types of data. Right? NumPy is specifically for numerical type of data. Pandas, once it comes into play, then you have the capability to work with any kind of data. Right? Could be text, could be categorical, could be objects, could be numbers. Anything can be there, and you can actually use Pandas to work with those type of data. Which again, another reason that makes it a good choice for data analysis. Right? So we're going to import the library. Let's move on. Pandas, we talked about the format, we import libraries, right? Import Pandas, and then as PD is kind of an option. It's kind of an alias that you use. Alias to say, I want Pandas to be known as PD in this notebook. Now, do you have to say as PD? No, you can just introduce it as any name you want. But it's kind of an agreement at this point that if you look at anyone's codes, you see that they import NumPy as NP and Pandas as PD. But that's not really, it doesn't mess with anything you do if you import it with a different name. So I'm going to run this and import the library. While it's importing, I want to talk about the most important part of Pandas that we're going to work with, and that's data frame. Right? So we saw arrays, like one-dimensional, two-dimensional, three-dimensional, n-dimensional arrays in NumPy. Now, Pandas is specifically designed to work with tables, right? That's the way at least we know tables and data. So it comes under the name of data frame, but you can think of it as a typical table that you see any other software, Excel or any other like R or C code that you work with. Right. Some terminology, right? Columns are columns. We just call them columns in a data frame. Rows, we call them rows, but they're identified by an index. Right, and we'll talk about it, how to actually introduce the names to index and how to create a data frame. And each column, which I'm not going to go into details about that, each column by itself is a series in Pandas. Now, what is a series? There are some slight differences between series and data frames. We'll see a couple of differences, at least the way they are represented, but the main difference comes into play or comes up when you start looking into how to use your data for a different purpose. Some specific functions or machine learning tool you want to use, some of them need you to feed the data in the form of series, some of them needs you to, some of them ask you to feed the data in the form of data frame. Right? Most of them are data frame, and that's why we are not really focused on series. But I put a link there if you want to get more into what series are and how to work with series in a data frame. You can take a look at it. All right. And of course, let me know if you have any question with that. Now, let's just jump into it. We are going to spend a good amount of time working on data frames that we define in the class. At the end, I'm hoping we get to work with data, and maybe we can also have some time so you guys can create a GitHub account. If you don't, then we just start looking into some more real life stories or situations. All right. All right. So how to create a data frame? Basically, the dictionary that we defined before, one of the ways, we'll look at multiple ways of creating data frames. One of them is just to define a dictionary and convert it into data frame. Now, if you do that, right, the keys in your dictionary are going to be your columns names, and whatever is the value for each key are basically the values for the rows, right? Let me run this. It's actually easier to see. Right? In this case, I have my keys as state year and population, right, which basically turn out to be number of columns. They become column names. And then you have your values for each key, right? And the values are going to be in that column. Now, be mindful that since it's going to be turned into a table, all these values should have the same length, right? If I change this to, let's say if I make it a little shorter now, the dictionary is fine, but then can't create a data frame because we are looking at the tabular form of the data. So all these features which we'll talk about, your columns should have same number of values. So that's the most common way, I would say, typical way you'll see we create a data frame. Now, here's a nice thing about the new version of Google Colab, that actually right there, I used to tell everyone how to actually bring a specific feature, but nowadays they put this very nice icon at the top right. If you click on that, you get a different form of visualization or representation of your data frame, which is more close to probably or used to maybe using Excel or those spreadsheet software packages. And you can filter. I mean, this is a very small data frame, but right there, without even writing any code, you can actually filter it based on the name of the columns. If it was a huge data set, right there, you could just say, I want to only see the data from 2000 to 2002 or 2001, maybe. So right there, without even putting any command, you can have a quick look at your data set and get a sense of different ranges or filter by different values, right? It didn't exist before, but now it does, so it's pretty cool. All right, now a couple of common methods when you're working with data frame. It's .head, basically shows the first 5 rows in your data frame. If you have a huge data frame with thousands and thousands of rows, if you just run that, it gives you the first 5 rows. You want to see, I don't know, first 7 rows, all you have to do is just put 7 in that parenthesis, and it just shows you first 7 rows. Right? Do we even have 7? We don't really, so let's make it shorter. Maybe first 3 rows. So you can do that. Method tail, similar story, but you can look at the bottom of your table. And if you have thousands of columns in this data frame, maybe it doesn't really show its advantage. But if you have a huge data set and you want to take a look at last 2 or last 5 rows, you can just use tail and then mention how many rows you want to look at. You can rearrange the order. That happens a lot. You import the data set. And in this case, we kind of fabricated, we defined it using a dictionary, but you can rearrange the columns, right? You can just say, well, the data, which was a dictionary, right? If I go all the way up, the data is just a dictionary I defined. Now I'm saying the command pd.dataframe, which converts my, in this case, dictionary into a data frame. I have an option to actually say, what is the order of columns I want? You just right there, you can decide about the order and you get the same order in your data frame. You can add a new column. Very straightforward adding a new column. It's kind of similar to working with NumPy arrays, actually. Once you have a data frame, when you want to add a new column, the name or the way you are adding keys and values to dictionaries. You define the key, which would be your column. In this case, I added area, and I define the values for that column. Again, the order should be in the same order as the state, for instance, in this case you had. But that's as easy as that. You can just add new columns to your dictionary data frame. Very similar to the way we add key and value to dictionary. We can drop a column, right? That you have seen before also. If I run this again, just to have the original data frame, you can drop a column the same way we were, again, similar to the way we were dropping keys and values in a dictionary, right? You can just say .drop as a method, mention the column that you want to drop, and remember in place. Drop does not really change the data frame. It drops the column. If you want to keep a copy, you can put in the new data frame, right? Say frame 2 is equal to this drop. Or if you want that change to happen or be applied to your data frame, we just put in place.true, meaning that that change has to be in place. Okay? And then you're going to just lose that column. You can see a list of columns. Again, in this case, might be a little trivial, but you will see data sets with thousands and thousands of columns, and we call them later on features. So if you have, I don't know, 500 columns or features in your data set, you can just get a list of it. Better, if you want to check if there is any specific variable or feature that you're looking for, that name is one of the columns names, you can just use the command in, right? I think we talked about in previously. So you just say, whatever is the name, I want to see if whether or not it's in the frame columns. And the output is basically a Boolean. Whether it exists or not is going to be true or false. All right. You can actually define indexes, right? As you saw in my data frame, indexes were created basically from 0 to 5. Right? I didn't really do anything with indexes, those values. They're just there. Gonna refresh your memory. Look at this. This is my data frame columns. The first column is index. It's just automatically created. So we can use it to refer to whatever row we want to choose later on. Right? But it doesn't have to be 0 to whatever number we are looking at. You can actually define it. Simply, if I define this data as a dictionary, I can simply add the option index when I'm converting the dictionary into a data frame. I'm going to say, well, convert this dictionary into data frame. This is the order of the columns. First column year, second column state, third column population. And here is the name of the rows. Right? I wasn't very creative, so I just used row 1 to row 6, but I'm sure we can come up with something better. And you can see a list of indexes. The same way you can see a list of columns, you can see a list of index, right? We have the method.index. You can see a list of indexes. The same way you can check if any specific index is in the list of indexes. You have all these to work with. All right. So here is something for you to play around with what we just talked about. Define a data frame. I gave you already the dictionary. So define a dictionary, convert it into data frame, and do this. Show the first 3 rows of a data frame. Add this one as a new column to your data frame. Drop the column rank and put it in place. So it actually makes that change to your data frame. And check if the label area is one of the column labels. So slicing. Right. Same story as NumPy. We have to be pretty comfortable with the slicing and basically selecting a specific portion of our data frame, or think of it as table for now. How does that work? Well, it's, let's define this data frame, and I actually intentionally define the rows with indexes R1 to R6. Now, there's a slight difference the way you select in Python, in Pandas, and in terms of output. There are multiple ways of selecting. We'll look at it. But for instance, if I want to select a column, I can just easily use the name of the column. But if I use a single bracket, right, I get an output which is in the form of a series. If I use double bracket, I get an output which is in the form of a data frame. And so there is a slight difference. Again, it depends on what you want to do with it afterwards. You can slice with 2 columns. Let's say the column year and state, and you want the output to be a data frame. Okay. Let's look at the first 3 rows they output. Just easily just use the name of the column. Now, you want to select rows the same way we were approaching NumPy arrays. Right? The whole story of it starts from the beginning, it ends at the number before the last number. Right? We do not really include the last one. So if we want to have the first 2 rows, we can just easily say from 0 to 2. Right? So we're going to get rows 0, 1, and 2. Alternatively, you don't even need to mention anything. You can just start from wherever is the start and use colon. You've seen this when you were working with NumPy, so it should be familiar. All right. Now, this is just the general form that we can basically treat these data frames as NumPy arrays. But Pandas itself has 2 methods, lock and iLock, that you can use for slicing. Now, the main difference between 2 is that lock, you use the names, either name of the column or name of the row or indexes, better to say. iLock, you use the numbers. So you specifically say which, whether it's column 1, 2, 3, you have to specify the column order. When you're using iLock or row number, when you're using lock, you can use the names. Let's see how does that work. All right, so here's some random data frame I defined. Right, made up. Columns are Ohio, Texas, California. Rows are A, C, and D. Okay. Now, as I said, here's the lock, the general form. You have your data frame. Lock is just a method. Say .lock. You identify the row label, which is index, and the column label. As long as you do that, again, pay attention to the way the output comes out, or the form of the output. The data type changes. If I use 2 brackets when I'm selecting the column, right? Using iLock, remember, using lock is basically the name, right? I'm saying I want the row A. So if I use double bracket, I get a data frame. If I use a single bracket, I get a series. For now, you don't need to be too worried about that. But later on, just remember when I refer to these, because the output matters. You can select 2 rows, right, using lock, and say I want the row C and column Ohio, just one specific cell. Now, if you want even one cell to be a data frame, all you have to do is just change these single brackets into double brackets. Right, so you say I want this to be a data frame. Now, in this case, maybe it doesn't make too much sense, but you can just get it either as a data frame, whatever is the output, or just as a number. If I don't use those brackets, I just get a number, whatever is in that cell, row C, column I. Now, of course, we can do multiple. Won't be fun if we couldn't. You can select rows A and C and columns Ohio and California and get a data frame. Now, this you can't really, not in a meaningful way, you can get a series because it's actually a table. All right, so that's lock. Again, remember, lock and iLock, the difference, lock uses names, iLock uses the numbers. That's it. All right, so iLock, very similar format. You use the row index and column index instead, right, when you're making a selection. How does that work? Pretty straightforward. Let's say you want the specific row. Right? So I want the first row. Right? And I'm using double bracket here, so I get an output as a data frame. Let's say you want to select row C and column Ohio. The same thing we did with names. Now we can use it with numbers. That is the second row, first column. Right? And you get a data frame. So it depends on, sometimes you know the name, sometimes you know the order, whatever you have access to. All right, so 2 rows and 2 columns, the same story as names, but in this case, just I'm basically running the same examples, this time using row and column indexes. Now you can do pretty cool stuff, and sometimes you have to be careful not get into trouble, because I'll show you an example. In this case, I say in lock, using the lock method, I want all the rows and columns from the beginning up until Texas. All right, so it includes Ohio and Texas. Now, let me go to the next one. That's a better place to talk about. All right, the next one, I say I want to start from row C, all right, to the end, and I want to start from the beginning to column Ohio. All right, and Ohio is the first column, so I just get one column, 2 rows. Now, if I change this, see what happens. This is something you might get into trouble. If I just remove the column, if I have the column there, I get a data frame. If I remove this column there, I get a series. So sometimes you have to be a little careful, maybe doing some experimentation even what you're doing. Make sure you get the correct format in output. Again, very similar to NumPy story, but the main difference is that now you actually have capability to work with the column names and row names and indexes both. So iLock, a couple more examples there just to get a sense of what happens when you play around with indices, right? In this one, you say you want all the rows, you want columns from the beginning to second column, and pay attention to the difference. When I use numbers, I get column 0 and column 1. But when I put Texas, I actually get the column that includes Texas. So I get the first column and second column, and when I put the name of the column. But if I want to use numbers, I have to go one column ahead because counting stops in the column before. So small things. You don't need to memorize this, but for a lack of better word, sometimes don't be too confident about your code. Maybe do some little experimentation and make sure you're doing the right slicing. Right? Because things can go wrong with just small changes. All right. All right. The last thing is this one. Same story. Just be careful about the numbering. Right? Where you start, where you end. Same thing as NumPy when you work with numbers. All right. So I put a table there. These are mainly working with series, and the output of these are series. Some I talked about lock and iLock. I didn't talk about the at method. Specific number. Right? Obviously, you can just use the method we talked about before, but that's a different way of doing it. Or I add if you know the specific cell column number, you can use I add. You asked me what is the difference. There might be some very, very slight differences in terms of performance when you are maybe doing production and writing codes. But to the level that this I've worked with, really it's a matter of the way you code. I brought one example here. Basically, the whatever is the value at row 0, column 1. All right, here is the question for you. This you actually have to create the dictionary. I put a link there to a Wikipedia page because they keep updating that page, so I never get to put it as a dictionary. These are the list of, I think, fastest cars, at least from the last experimentation they've done. You can find the table right there on the Wikipedia page. Later on, hopefully closer to the end of the semester, I'm hoping we get to talk about web scraping, and we can actually learn how can we scrape the web page that we want and get the data we want. That's a little more advanced. We'll see how things go. But for now, I want you to create a dictionary with the first four columns of car, model year, propulsion, and time, right? And take the first 5 cars. So starting from Tesla to Lamborghini. These 5 cars so you should end up having a data frame with 5 rows, 4 columns. just copy and paste those and create a dictionary, convert it into data frame, and see if you can do what is asked based on what we just talked about. Of course, you have to be able to sort. And you can't really work with data without not sorting. The sorting comes up here and there. Whether you're using any kind of spreadsheet kind of space software or any other programming language. And of course, we can do it in Pandas. All right. So we actually have just the method sort underscore index that we can use. If I define this data frame, it's a little, just to go over a couple of examples to get a sense of how does this work, because you can sort in different ways. Right? You can sort along index. Right? You just basically, the default value, you can just say sort index method, and there is no input for that. Right? You define your dictionary. I define this dictionary with some random numbers and letters because that's going to help us to actually play around with sorting. So if I sort by index, right, and if you look at the difference between what we had and what is sorted, it basically just looks at the index values, right, or think of them as row labels. We have 2, 1, 4. Of course, when we sort it by index, now it's going to be 1, 2, 4. Right? So that's the default. Now you can sort along axis 1. I remember we said in Pandas, in NumPy, and obviously as a result in Pandas, which is based on NumPy, we do have the tendency to talk about rows and columns, but at the end of the day, the way it's programmed, it talks about axes. Like axis 0 is going from the top to bottom, like these rows. Axis 1 is talking about columns. Then if you have 3-dimensional data, you have axis 2. If you have 4-dimensional data, you have axis 3, and it keeps just going that way. So if you want to sort it based on the values in rows, then you can just use axis is equal to 1, right? The name of the, better to say the name of the columns. If you want to sort it based on the column names, you just change it to axis 1. So with sort underscore index, you have the capability to sort it based on the rows, names, or column names. All right. Not very helpful so far, because we barely do that unless we can set the index. I'll talk about it. Now, one thing before I talk about sort values is sort is also not an in-place kind of, by default it's not in place. So it doesn't make the change, it doesn't apply the change to your data frame. If you want to make it happen, you have to put in place equal to true, or you can just sort it and put it in a new data frame, put a new name and keep that copy for yourself. Now, the sorting that we probably use a lot is sort underscore values. Right? That's the one that we work with here and there, because in so many cases you want to sort based on the values you have in a column at least. Right? And that's where sort underscore values come into play. Now, you just have to identify the column pretty much. You use sort values and say, I want to sort this data frame by a specific column. Right? In this case, I say sorted by column B. Right? So, and by default is from the lowest value to the highest value. Now, you want to change that. You guys have to be more comfortable with this. Let me hover my mouse here. Hopefully it works. Be comfortable with documentation, especially in Google Colab. You just hover your mouse over the function. Right there, it gives you a full description of all the options. If you scroll down on that, it gives you examples of how to implement it. So be a little comfortable with that. If you look at the options there, you see by default ascending is true. So it goes from the lowest to highest. Now you want to change it, you can put ascending is equal to false. So it's going to sort based on from the highest to the lowest value. Right? So if I have from -3 to 7, all I have to do is put ascending is equal to false, and then I have the column B sorted the highest to lowest. Now you can sort based on 2 columns. And even more, as many as you want. What does that even mean? Well, if I sort by A and B, or it depends on the also order I put. So look at what happens there when I sort it by A and B. It starts sorting by A, like that's the main column. So it puts 0, 1, 1, 2. Now, when it gets to the two similar numbers in column A, it looks at column B and decide how to order it, how to order the rows based on the values on column B. Now, if you had more columns, if you were sorting by more number of columns, every time it gets to a repeating number, a similar number in one column, it looks at the column after and see if and sorts it based on the values there. Right? Same story, you can change ascending and descending order of this. All right, here's the question for you guys. Use the data frame you defined for question 2 and do this, do some sorting and play around with this. So a couple of things that Pandas obviously has, and we have to kind of look at it, is descriptive statistics that you get in any software package, right? If you're using R, you get it immediately. If you're using MATLAB, you typically can get it. Pandas provides that to you too. Right now, you created a data frame, and in this data frame, just be mindful that it put some of the NaN numbers or values, which basically not a number, meaning this happens when you import the data set, and there are some values which happens a lot, almost always with real data. There are some values that are missing. So we're kind of making some fake 2 columns. And let's say the column A doesn't have a value for, row A doesn't have value for column 2. Row C doesn't have any value for these 2 columns, whatever that was that you're measuring those features. So this is your data frame. The reason I did that is because I want to show you that Pandas can handle missing values. Right? So you decide whether or not you take them into account. Now, the most typical one, right? The most typical one is you want to sum maybe the value, you want to sum some of the numbers in a column or some of the numbers in rows typically, and this works very similar to the way that sum works in NumPy, right? Because as I said, Pandas takes a lot or gets a lot from NumPy. So if you run this, by default, you actually get the sum of the values, right, that are for columns, which is a typical thing that we usually want to do. We want to sum some of the values for a specific feature. So sum of those values for the column. But in case you let me change this. In case you want to find it along the rows, right? Remember again the whole story of axis 0 and axis 1. Right? Axis 0 is whenever you want to do something down the rows. So you want to go, let's say, or think about it this way: you want to do something on columns, right? That's your axis 0. Axis 1 is whenever you want to do something on the rows. Right? So it's very common in a lot of methods that we have in Pandas. Whatever the default is, right? Typically one of them is the default, the other one you have to specify. So either axis 0 is the default, and that's almost always for all the methods that I can think of. So we get that operation for all the for each column, or whatever the outcome of that operation is. In this case, summing the values in a column. If you want to do the same across, you find the sum of the values for the rows. You just have to specify that axis. Now, I did put axis equals to columns, but you could just change this to axis equal to 1. That column is just there for us to feel more comfortable with rows and columns. But 0 and 1 is the main language of Python, typically, and NumPy. Right? Now, pay attention to what happened. By default, Pandas go ahead. It goes ahead and it takes care of the missing values. Right? If you look at the sum of the columns, let's look at the column 2. Right? The sum of the values is basically just 4.5 minus 4.5 and minus 1.3. Right? Discarded those missing values and said, okay, there are missing values. Let's ignore those and just sum of the values. You have the option to take into account those missing values and let's say get an output that kind of indicates that there are missing values in your column. Like by default, Pandas ignores those. But there is an option, skip NA, which by default is, I think it basically, let's put it this way, it doesn't take missing values into account. But if you want, you can kind of change this value. Right? I think the default is, double check, is on the none. Yeah. So you have to kind of set it to whatever you want to do. If I change this to sum and then skip NA is equal to false, and I run the same operation. Now here's what happened. Let's do it for the columns that we were talking about. So I put a skip NA is equal to false. Now I get missing value for both columns because I have missing values in those columns. Okay? So it kind of indicates it's not the best way, but it's one way that you can figure out there are some missing values in that specific variable or feature that you're measuring. And you want to make sure that Pandas doesn't skip those missing values, right? But by default, it's untrue. You don't really need to set it untrue. By default, it just ignores those. All right. I said it depends on the case. Sometimes you want to take them into account. Same story about mean, finding the average. Same way of setting it. You want the average for columns or you want the average for rows. Whether or not you want to take into account the missing values. The important one that is kind of, it gives you all the typical statistics that you want for a lot of numerical values you're measuring is describe. Now, whatever is the name of the data frame, you can just use .describe as a method, and that gives you almost those 5 important statistics that we care about. Right? It tells you what is the mean, tells you what is the standard deviation, minimum and maximum, and the median. All right, the median would be 50%, 50 percentile, 25% percentile, 75 percentile, and 50 percentile. So you get all of those as long as your columns are numerical values. Now, if your columns are not numerical values, describe it by default. This method operates on numerical values. So if you have columns that includes different types of variables, like categorical variable, right? So you're measuring something and there are a couple of categories. I don't know, maybe some data set with people's hair color or eye color, and you have specific categories, 3 or 4 repeating, or there are some characters. The column includes words and letters. Describe is not going to really give you anything for those columns by default. Right? So I defined a data frame, right? One column with numerical value, one column with categorical value, one column some characters, objects. If I apply describe, right, I only get the output for the numerical values, right? Because, well, obviously standard deviation, mean, 25 percentile, these only make sense for the numerical values. Now, there are options in describe that you can use, right? I can say, I remember I can say include all as an option. But once I do that, then you actually get statistics for non-numerical values. Now, of course, what you get for those is different, right? You get count, how many categorical values you have, values you have on that column. How many unique values do you have? And you might have categorical values with 5 categories, but you have 5,000 rows, right? Only 3 unique values. What is the most frequent one, right? It's the what category that is. How frequent that specific value is being repeated in your data set. So you get these for non-numerical values. It depends on what you want to get out of describe. So it works both on numerical and non-numerical variables, but of course it gives you different outputs. It gives you, if you want to, all you have to do is just to include everything. Now, off the top of my head, I cannot remember. Maybe I can see it in the documentation that there is a way to just get include the values for non-numerical. Do some digging. Include all includes everything. There is a way to get just for non-numerical. Well, there you go. So we can say include object or include category and just get the descriptive statistics like count, how frequency of each category, what is the most common category for the specific variable you're looking at, whether it's an object or it's a category or categorical variable, or just an option adding to your command. All right, that we use a lot. When you import the data, you just run a describe, and you want to get a sense of what values or what are the range, what is the skewness, how things are basically distributed. All right, it's not just these. Of course, there is a lot, and I put a table of those there. Count is something we use because we want to count the number of values in a column or number of specific categories in a column. And it skips missing values. So count is one way to find out if there are missing values in a column. Right? If you have the dimension of your data set, let's say you know it's 1,000 rows, and you count a specific column, apply count to that column, and you get less than number of rows, it means there are some missing values there. I don't go into these. These are a lot. Some of them I personally don't use that much. Some of them are a little tricky, like argmin and argmax, or idx min and idx max. If you want to use them, you have to do a little bit of digging. You have to actually they work on row indexes. So you might have to make some little changes here and there to implement them. But I'll leave those to you. We don't need to go into details of these. I think one that you might be interested is DIFF. Basically, if you want to calculate the derivative of a specific variable or a specific column, you can use DIFF, which basically finds the difference between rows, and then you can divide it by some maybe another range, delta x or delta t, and basically that estimates the derivative for you. But that's a different story. All right, so give you some time, play around with question 4. You have the data set already. It's a pretty easy question, but use that time to implement some of these methods, whether the ones we talked about or the ones from this table. We can actually talk about data sets. We saw everything playing around with data frames. The bottom line is when you import a data set to Python, 9 out of 10, you want to convert it to a data frame. And everything we just talked about, you basically use those methods on your data set or data frame. Now, Python has a lot to offer in that case, or Pandas, better to say. Depending on what data set you have, right? Starting from a CSV file is the most common file to if you have a SQL file that you created some database in SQL or MySQL somewhere and you're trying to import it. If you have some SAS file, if you're doing statistics in SAS somewhere, you can bring all of these to Python. Right? So just some of the functions that are coming as default by Pandas. Now, there might be some software packages out there. They give you some specific file extensions of format, where to say. Always look up. Almost 100%, I would say, close to 100% chance that somebody somewhere wrote a specific function or program for you in Python that you can use to import that specific kind of data and convert it into data frame. The ones we're going to use in this class mainly CSV and Excel, because that's the typical data sets we're going to work with. But if you work with SQL, you can look at read_SQL. We hopefully get to work with JSON files, which are pretty cool stuff, pretty cool things that we can do with JSON files. But if you have a JSON file from somewhere else, you can read it with read_JSON. Each one has its own way of dealing with, and of course, again, I refer you to the documentation. So many options that you will see with each one of these. All right. Now let's start the CSV file. Now I did put a CSV file. This one is a data set that we are gonna here and there we're gonna use it. It's basically just a set of data for a series of airfoils that they measure the noise. The experiment was done by NASA. I don't remember which year, but it's mainly focused on how much noise any airfoil profile creates under different frequent wind speed. Right? So I put the data on GitHub. Now, hopefully, I think we have time. We're going to go through this process, and you guys create a GitHub account. And GitHub is pretty much somewhere that anyone who is doing programming is dealing with. Right? Website that you share the codes that you write. You can put your data to some amount of data there. A lot of people doing work collaboration, they use GitHub for code sharing, or if they develop a specific product, they put it on GitHub so that people can actually report bugs or download the code. So hopefully we're going to do that today, so you can have your account. But I created an account, right? I have an account. I created a repository. We'll talk about it, and put this data set there. And this is basically just a CSV file on the internet. Think about it this way. Right? Save somewhere on the internet, you can get a link to. Now, this data set, if you click on that link I put there, it's just the raw data. Right? This is just basically a bunch of comma separated values. Right? If you click on the airfoil noise CSV file, right, it takes you to some tab, a lot of rows. Right? No names for columns. All right, so there is no header for the data. But I did put a README file basically describing the data, which again, you put it on GitHub. If you click on that, it tells you what are the features in that CSV file. So it tells you the first column, the first value on each row is basically the frequency in hertz. Right. The second value is the angle of attack for that airfoil, wherever they put in some wind tunnel. The chord length, right? How long that airfoil is, and a couple of more variables. And the last column is basically the sound pressure level, right, in decibels. So if you look at this is your sound pressure level, whatever they reported that. Now, this is not the full data. I got this data. I put the link there, right? It's UCI, basically a website that we kind of referred to in the first class, and we're talking about where to get the data. You can always go to that website and look at the description. Typically, that website provides you with even some reports, scientific reports or papers published based on this data. So those reports and papers even have more information about how did they collect the data, what were the restrictions. When we start talking about the data cleaning, I'll talk about it. The first step you are given when you're given a data set is to get very comfortable with what you have in data set. What are the variables or features? How did they measure it? What are the restrictions? Who made those measurements? Who was in charge of those experiments? You need to know all of these, right? Or at least you have to try to get to know as much as you can. All right. So read CSV, pretty straightforward. I put the link to the website, to the CSV file I put on GitHub, right, as a string. And I use the command read CSV. Now, as you can see, if I hover my mouse over this, the number of options that you have for read CSV file is, I would say, amazing, for lack of a better word. You can set a lot of things there. Some of them we'll talk about. Right? A lot of them, it really depends on the file you're reading. Right? You may or may not need it. In this case, the file we are reading, the CSV file we looked at, has no column labels. Right? So there is no name there. So when we read this file, we specifically say header is none. Just so you know, there is no header. If you don't put that, I'm not sure. We have to experiment with that. I'm not sure the default is none or default is true. Default might be none. Whatever the if you put it on true, or I have to double check. But in one scenario, let's put it this way. It takes the first row as the labels if you don't specify. So it's going to use the numbers on the first row as the name for columns. So with header none, we're specifically saying there is no header in this file. And with names, I'm specifically introducing the name for those columns. Let's see if I do it this way. And I'm going with the same order as the README file. It was telling me the first column is frequency in hertz, the second column was angle of attack, and keep going to the last column that is the sound pressure level, right, in decibel. So once this file is imported, right, the output of read CSV file, CSV command, or better to say method in Pandas, is a data frame. What is that data frame? Well, all the values there, no header, but I specifically mentioned what are the names of the columns. And then we can look at the first few rows. I specifically said 10. Don't know why we can only look at just 4. Right, so first few rows. This is your data now in the form of data frame. Now everything we talked about data frames, we can do on this. That's just the step that you go from defining a data frame in your Python to actually working with data. Now, in case you have the file in your computer. Now, if you're running Python on your computer, you don't really need this step. But since you're working with Google Colab, and if you have the file on your computer, you do have, this is kind of a boilerplate. This is something that Google tells you to do. You just import IO, which is input output library. And then from Google Colab, you import file. And then that allows you to upload your file. Right? To test with that, I can actually share with you the same data file, the airfoil noise, and you can read it from your computer. Because as you go through the course, you probably have a lot of data or whatever you want to do. You have your data on your computer, not on the cloud somewhere. This is something you can do to just bring your data set to your notebook. And you run this one. I think it's straightforward. This shows up. It tells you to choose the file. Click on that. Choose the file wherever you have the file. If I can find it somewhere here. And if I import that, now, once you do that, the file is in the memory. You still have to read the file. To read that, you still have to use read CSV. Now, with this a little bit of weird way of doing it. All right, input, output, the library imported, bytes, IO, and then the uploaded file. Pay attention, here goes the name of the file, right? Whatever you uploaded there, you have to use the name, same name here. So in this case, we can see the name is airfoil_noise CSV, right? That means here it has to be airfoil noise CSV as well, right? And the rest is the same. There is no header. The names are these for columns. So running this, you should get the same data set, but just reading it from your computer, right? So just make sure the only thing that can go wrong is the name. Well, a lot of things can go wrong usually. Life. But airfoil noise CSV, the name should be the same when you are reading it with CSV. So 2 steps. You upload it to your memory and then read it from the memory and then put it in a data frame. All right. All right. Question on this one, guys. Good. So you either have your file on the cloud somewhere, you have the direct link to it, or you have it on your computer and you can read it. All right. And the same story, remember I mentioned, very nice feature on Google Colab. You can click on that and convert it into a kind of table that you can actually start filtering and play around with the values. right? Quickly get a sense of what are the values we're looking for. All right, so what if it's Excel file? I did put Excel file on GitHub, which we're going to talk about how to do that. This is also a data set we're going to work with here and there, depending on what we want to do. Right? This is a result of a bunch of vehicle testing by EPA. Right? And if I click on that, you actually have to download it. So let me open it on my computer. And then let's take a look at that. I don't remember how many rows does this have. We're going to check. The car model, the engine capacity, number of cylinder, the type of transmission. They made a lot of measurements. And by the end, which we are going to look into this data set specifically at the end, they come up with some scores, right? They measure what is the mile per gallon in a highway, what is the mile per gallon in a city environment when you're driving this car. And at the end, they come up with some score, greenhouse gas score, and or whether or not it's a smart way. Now, what are these? We'll get to this later on. So don't be too worried about it at this moment. But EPA has its own way of categorizing, and we're going to look at the description of how did they come up with this specific greenhouse gas score or air pollution score for each car. Right? But this is just coming from a set of experiments. Now, to read the CSV file, now, as you saw, this one does have column names. So I don't need to do anything about the header. I don't need to specify that I don't have a header. I don't need to mention a name. The only thing is there is an extra step with Excel file. You have to bring in the Excel file. Right? I can't just read it by read_Excel. Why is that? Because Excel files have a lot of tabs. This one has only one tab, but you can have multiple tabs on your Excel file. So the first step, you import the Excel file, bring the whole file in, or read the whole file and put it in some variable. In this case, I put it on XLSX. And then you read the tab or sheet that you want. Whatever the name of that sheet is. In this case, I only had one sheet, so I'm just reading sheet 1, and that's pretty much it. And that's the name of the sheet. We should move it. So it's there is an extra step involved. Right? You bring the file and then read the sheet that you want the data from. Right? If you want to read multiple sheets, you can just do it the same way. But you have to bring the file first. All right. So just keep that in mind. Now, read Excel is just going to give you a data frame. So again, the same story. You have your data frame. If I run this, I have my data frame, and I can do everything I just talked about on the data. You can sort it, you can slice it, you can take the data you want. All right, so these are the main two files we're going to work with. I'll talk about GitHub, but let's finish talking about the JSON files. I just want to briefly mention that they exist. Very flexible format, and that's why they're pretty common. You're not restricted with the whole table format anymore. So a lot of geographical data, a lot of web pages that you read, they're going to end up looking like this as a JSON file. Now, working with JSON files can be a little tricky. So when we'll see how it goes, but when we talk about web scraping and getting the data from a specific place on the on a website, we're going to end up dealing with JSON files, and we hopefully get to play around with them and get a sense of how to work with JSON files. Yeah. But just, they're pretty flexible and they're very common. They come up over and over. All right. Before I talk about miscellaneous, I want you to create, let's see if we can do it together. If you go to GitHub, type github.com. If you have an account, great. If you don't, let's see if we can make one. Let me log out. So go to GitHub, just type github.com and sign up. Shouldn't be. They made it very fast. Enter your email, follow the process. I can create a new one. Password I have to create. That works. Username. Password. Show me. Make it one up. Not available, so I can use that. Oh. Maybe 00. There you go. Hopefully you guys are doing the same steps. I want you to have a GitHub account by the end of the class. So go to github.com, click on sign up. Ask for your email, ask to for a password, come up with a password and any username that you can come up with. All right. So you should see something like this eventually at some point. All right, so there is not that much there, as you can see. Well, in a very informal way, pretty much in GitHub, we can create repositories. We can think of them as not really a folder, but repositories. You can create one repository for each project that you're working with. You can share that with people. You can put everything related to the project. You can create folders on the repositories, put files there, and that's what we're going to do. All right, so let's create a repository, and let's just name it ME364. Now you have the option to make it private or public. I suggest just leave it as public if you don't want to really do anything specific coding. You can add a README file there, and then that's pretty much it, all we need, and just create the repository. All right, so there is not that much there. Just empty repository. Now, this is where you can put all the files, the same thing I shared with you here, like the CSV files and the README file and everything on the cloud, you can put them all there. Now, how do you do that? Oh, it depends on how organized you want to be. We can create a new file, and maybe it's better to have folders instead of dropping everything there. We can just say airfoil data, and then if you click or press /, it's going to create a folder for you. So again, let's cancel changes. I'll do it again. You go to File, Create New File. It's asking you for name of the file. What if you just put airfoil data and press /? It's basically, it's going to create a folder for you. And then you can create a README file inside that folder. Let's say, write what you want. This is the data for airfoil noise measurements. And feel free to actually copy what I wrote there. Data set for the experiment done by NASA. I'll leave it here. You don't like long lines? Just push it to wrap the lines if it goes further than the page. And I can copy and paste what I have in my README file. I can click on that link, put it here. So now, sure. Now you can actually now I'm here. Right, I have my README file, everything written in it. Now I have to commit. So we go scroll down. Let's just keep it in the main branch. Another great practice, but then you can just click on commit new file. And basically with that, you are creating the file. Right? So in your folder right now, in your repository, better to say, now you have the folder for data. You click on that, you have the README file inside. And the README file, whatever you have, typically just shows up in that repository when you open that folder. All right, now you can put your file here, there, and now I want to add the data file here. I go to add file and I go to upload files. Click on that. Again, I think pretty straightforward. You have to choose your file from your computer. So you can select the airfoil data noise, airfoil noise CSV file, and upload it there. So again, I went to cancel this. In my repository, which I named it ME364, I create a folder there. I went to file, upload files, and then I choose my airfoil CSV noise. Click open. It's there now. I have to just commit. So press commit changes. Shouldn't take that long, and then you're inside your airfoil data. Now you have your README file and your airfoil noise CSV file. All right, so now you want to read this in your notebook, right? Click on that. It'll take you to this page. You can see the data, right? If you click on the CSV file, but this is not where you can read this from. You actually have to have the link access to the raw data. For that, top right, click on the raw button there. That takes you to where you want to be. And that is the link that basically I shared with you on a different Google, on different GitHub account. But this link is what you can just bring here and use read CSV and read the file. Now, of course, it's not just about files, right? GitHub, a lot of it goes back to sharing codes. Right? So if I go back to my airfoil data, let's see if I can upload a code, and let's go for the notebook that we are using. I can take it down, but you can use that to upload your Python code, and this just commit. Right? You can actually work with it. The same thing I just opened on my computer. Now you have it on GitHub. Right? But you have the file there. You can actually get the link to raw data and raw file, or you can just download everything. So yeah, behind the scene, a lot is going on. So GitHub has a lot of interpreters for different languages, and it actually detects, you see, it detects the syntax. Right? So if it was the C++, it would have still identified if it was a Java code. It interprets based on the file extension, it interprets what file you're working with. So you do have a profile pretty similar to a lot of these websites. We can modify it. It actually gives people a sense of your contribution, how active you've been over last year, 2 years. A lot of people look at your GitHub file. They look at how active you were, how many projects you have done. If I go under repositories, well, right now I only have one. It's this repository. And already it tells me this is written in Jupyter Notebook. If you have a code, let me see if I can go to my other account. Now, if you have codes written in different places, right? So this is my other account. You have the Jupyter Notebook, you have Python, you have Fortran. If you have something in C++ there, it identifies that. If you go to repositories, it shows all the repositories that you've contributed to or you have worked with. Either you own it or you share it with someone. All right. So it's a great way of code sharing and actually working with keeping a record of everything you do, your projects, and any other work you do with the coding. All right. There are other things that I'll let you figure out. You can obviously delete the repositories. You can fork a repository, meaning someone else is working on a project. You can actually fork that repository and bring a copy of that repository at that time to your GitHub account and have a copy for yourself and make changes into that, to the codes on that repository and modify it the way you want without messing with what the original code is. These are the things I'll maybe we'll talk about it, and we'll see how things go. So like more on the other side. All right. So that's how you basically put your file and your code and everything, right? Basically on GitHub and have access to it. All right. So we talked about data sets. We should be pretty comfortable with data frames at this point. You bring the data set, they become data frames. So everything we work with on data frames, we have them now in our disposal. There are a couple of more things I put under miscellaneous that I want to go over. First is finding unique values. Now, when you use describe method, you were getting unique values as one of the options if you were looking at non-numerical values, all right? But specifically, we do have a unique method that we can use. Now, if we look at the airfoil noise data set, all right, I brought it in again here. If you look at how big this data set is, we can easily do it by just Python function length itself, right? Data frame 1. It's more than 1,500 rows, right? 1,503 rows. Now, if we look at the unique values for frequency, right? Specifically, I said, well, I want to know the frequency. What are the unique values for that specific column? I'll actually get only 21 unique values. So that's something you're going to use a lot when you're working with data sets. You are going to need to know the specific number of unique values for some feature. Right? That's something, just keep it around. You'll see it here and there. Now, something that's less common is var method. It's a little strange the way it works, but if you learn how to work with it, it's going to help you a lot later on when you're working with data sets. Var method basically lets you replace any value in your data set with whatever value you want, wherever the condition you specify is false. That makes more sense if you look at this example. I define this data set, some dummy variables, column 1, column 2, column 3, and the rows from 0 to 4, right? 5 rows. Now, here's some condition I'm applying. Before I do this, hopefully you remember this a little bit from what we were talking about with NumPy, working in Pandas. And if I apply the condition on column 1, basically I'm saying where are the places that the column 1, the value in column 1 is less than 3, right? And you get a Boolean output. Right? It tells you the row 0 and row 1. The value for column 1 is less than 3, so we get true, and then 3 falses. The other elements are equal or greater than 3. Now, this is masking. If you remember, we talked about masking. If I want to get that specific branch of the dataset or subset of the dataset that meets this requirement, right? I just say, well, that Boolean output mask my dataset or data frame, better to say, with this Boolean output. Right? So I'm only getting the rows in which the column 1 value is less than 3. Right? That hopefully makes sense. So. All right. So what does where do? Well, you basically say, well, method where I'm using the condition I just mentioned, and I'm saying, well, using this method, wherever this condition is met, right, which basically are columns, rows 2, 3, and 4, 3, 4, and 5, don't do anything. And wherever it's not met, wherever this condition is false, let's run this. Is false, replace the value with 0. Right? The last thing I'll mention is that selecting rows and masking in Pandas. The same story as NumPy when we're looking at numerical arrays. If we want, let's say, the part of data set that is first column value is equal to 2, right? You apply the condition, and you say what condition you're looking for. You use that to mask your data frame, and you get wherever you get the part of data frame that part of that condition is met. I put a couple of examples, equal and not equal, but you can do the same thing as greater than or smaller than, or all the logical operations that we talked about before. So here's the something I want you to do. Use the airfoil noise data set that we just learned how to import, and find out these two things. Find the number of unique values of sound pressure level, and define a new data frame that all the rows, it has all the rows with a frequency that is equal to 1000 Hertz. And use that time to just play around with what I just talked about in the notebook. Feel free to play around with that data set, with that data frame. All right. One thing that we don't really get to talk about that much, but I put a link there, is how to combine data frames. Now, that actually comes up more than you would like to deal with it. You're going to end up having a lot of files, CSV files, Excel files, you import it, you have your data frames. Then you have to somehow either combine these data frames, or you have to, parts of them you have to combine together and come up with a new data frame. I didn't cover it on this notebook, but I put a link there. A very good, thorough article talking about how to combine your data sets and how to join. Now, if you work with SQL, if you work with or any other programming language working with data sets, you might be familiar with the concept and how does that work. If you're not, this article assumes that you know nothing and it starts from scratch.